I grew up in Hampstead, and I'm going to now talk to you about my experiences with the site testing project in the 1970s. It's a kind of a snapshot of a bit of history from the last century, if you like, astronomical history. This isn't really a science talk, but I hope you find it interesting nevertheless. The outline of the talk. So it's in 7 parts. I'll try and get through it all in just over an hour. We'll see how we go. How I got into astronomy to start with, a background about UK astronomy in the 70s, the influences on site testing and the site selection criteria, the Northern Hemisphere Observatory site testing project, and then a separate project in Iraq, which I was involved in 1977, and then finally the legacy. And I'm going to pause after part 2 and after part 5 just for a few questions, just to have a drink of water, see how we go. And then right at the end, there'll be the opportunity for more questions. And if we have time, I hope to show a couple of short videos which show the legacy in terms of La Palma and in terms of Iraq as well. So how did I get into astronomy? Well, I grew up in Hampstead, and some of you may remember the winter of 1962-63, the worst winter of our lifetimes in this country. And I was 12 at the time. I think Andrew was 12 as well. And when the thaw eventually came, my mother resumed taking my sister and I to the Keats Grove Public Library to borrow books. And so I wasn't a particularly fast reader, but I did spot this book by Patrick Moore called The Amateur Astronomer. And I quite fancied it, so I took it home and read it. And so this gate here in the Keats Grove Library became literally my portal to the universe. And just as an aside, if you go to a public library anywhere in the world, you have a binary choice. You can do fiction or non-fiction. If you select non-fiction and go to the middle of the aisles, you'll find yourself among the 500s of the Dewey Decimal System. And there you will find books on astronomy, 520, 521, 522, etc. So if you ever want to bone up about astronomy, or indeed any other subject, go to a public library, select non-fiction, and within 5 minutes, you can be informing yourself about all sorts of things. So I took this book home, The Amateur Astronomer, and discovered that at the back of it were star maps. And so from my home in Hampstead, I could go out at night and start to identify constellations. Here, for example, is Orion. It's quite easy to find Betelgeuse and Rigel and the Belt of Orion and other surrounding constellations, the Hyades and the Pleiades, for example. Now, I actually had access to the roof of my house. This is a Google image, a Google map image of the roof of my house in Hampstead. And I don't know if you can see it, it's a sort of double hulled roof. If you imagine a catamaran that is capsized, these are the 2 bits of the roof. And there's a gully in between, and just here, you can't see it very well, there's a little hatchway. And so I could go up on a ladder into this roof space and then out from the hatch into this gully and look at the sky. And from this position, I was protected from artificial illumination, from streetlights and so forth, because they were hidden by the roof. I had access also to my father's binoculars. He had a pair of binoculars, not quite the same as these, but similar, and also a tripod. And if you mount binoculars on a tripod, you can see star clusters and things very, very clearly. And I was able to identify, for example, the satellites of Jupiter, things like the Pleiades, the Orion Nebula, and so forth. And that's how I started to learn about astronomy and become a bit of an amateur astronomer. I also joined later on, when I was a teenager, the Hampstead Scientific Society, which owns the Hampstead Observatory near Whitestone Pond. And it has this magnificent 6-inch Crook refractor. And I became one of the demonstrators at the observatory, which meant that I had a key. And so I often used to go up the road, about 15 minutes walk from my house to the Hampstead Observatory, open it up, and just look at things to my heart's content very much. And also on Fridays and Saturday nights, if the sky was clear, I assisted with the demonstrating of the telescope to members of the public. I also joined the British Astronomical Association, the British Interplanetary Society, and the Junior Astronomical Society. And it was because of my membership of some of those organizations that I became aware of an opportunity to work in astronomy. In 1974, I was the acting secretary of the Hampstead Scientific Society. And I'd been to a meeting of the Junior Astronomical Society in January, I think, of 74. And Alan Pickup from the Royal Observatory Edinburgh had given a presentation about the site testing project and had mentioned that they were actually recruiting. And then a few months later, I got a letter. A letter was sent to all amateur astronomy clubs in the UK, I believe, by the ROE, saying that they actually wanted people to, join them. This was the vacancy letter. So the Science Research Council, the Royal Observatory Edinburgh, as part of the Science Research Council, wanted to hire assistant scientific officers. They wanted self-reliant men accustomed to outdoor life to start in March or April 74 to work at remote observing stations on the island of Hawaii, on the island of Madeira. And you needed 5 O-levels, and you also needed a driving license. Well, I was fully qualified. And as an enthusiastic amateur astronomer with experience running a 6-inch telescope at Hampstead Observatory, I felt I was more than fully qualified. And I wrote a very enthusiastic letter to the Royal Observatory. And indeed, I was later interviewed for the job and hired to go to Madeira. And I went to Madeira in 1974. And I'll tell you more about that in a little while. Let's now talk about the background facing UK astronomy at that time. So in the 70s, oh, sorry about that. Oh, that's right, I beg your pardon. So let's talk about the organisation of civil science in the UK. So we have the Science Research Council, which is the main funding body, and that was responsible for things like institutions like the Royal Greenwich Observatory, Herstmonceux, the Royal Observatory Edinburgh, and other scientific organisations. It also gave block grants to universities. So, for example, Jodrell Bank depended on the block grant from the Science Research Council to run its radio telescopes, and also at Cambridge. And it also gave support for PhD students at UK universities. So in the 70s, we have, Jodrell Bank, Bernard Lovell, his telescope. We have the Anglo-Australian telescope. This is Fred Hoyle and Prince Charles at the royal inauguration of that telescope. We have the UK Schmidt telescope run by the Royal Observatory Edinburgh on the same site as the AAT in Australia, but that's in the Southern Hemisphere. In the Northern Hemisphere, we have the Royal Greenwich Observatory with its 6 equatorial group domes, and also the dome of the Isaac Newton telescope, the 98-inch Isaac Newton telescope, opened in 1967 on this site. There's the castle, the headquarters, and the rather nice gardens. The problem is that although UK astronomers had access to very fine optical facilities in the Southern Hemisphere, they didn't have access to similar facilities in the Northern Hemisphere. And while the radio telescopes at Jodrell Bank and Cambridge were making ground-breaking discoveries at radio wavelengths, the optical astronomers were not able to follow up on these because they didn't have access to optical kit on a good site. As you can see, this is a fairly typical day in Sussex. You've even got a double rainbow. Well, that's not a terribly good site for an optical telescope. And so there was a strong desire at this time to improve the optical facilities in the Northern Hemisphere. Now, the Royal Observatory Edinburgh was heavily involved in this, and Herman Brook, who was the director at the time, a very distinguished director, he proposed that there should be a large telescope, a roughly 150-inch caliber telescope, sited in the Northern Hemisphere. The Royal Observatory Edinburgh is also important because Charles Piazzi Smythe, who was the second director back in the 1840s, I think, at that time the Royal Observatory was at Calton Hill. It was subsequently moved to Blackford Hill, and this is the ROE today. He was involved in site testing in the 19th century. So he was a very important director from that point of view, and then Herman Brook proposed the new big telescope for the Northern Hemisphere. The idea really was to have something like this. This is Kitt Peak National Observatory in the United States, and what the British astronomers wanted was something similar to this on a good site in the Northern Hemisphere for their own use. And so planning started in 1971, and by 1974, after a lot of careful consideration, the Science Research Council approved plans for 3 telescopes on a first-class site. And the telescopes they wanted to create were a 4.5 meter class telescope. It actually turned out to be a 4.2 meter because of the availability of a particular mirror blank. So for technical reasons, it became a 4.2 meter aperture telescope on an altazimuth mount. They also wanted a medium-sized telescope, which turned out to be the Isaac Newton telescope, moved from Hurstmonceau and equipped with a new 100-inch mirror. The original mirror was a 98-inch mirror, but the new mirror was 100 inches, a full 100 inches. And then a smaller telescope, a 1 meter, for photometric work. So that was the proposal, and it was approved in 1974. And then, of course, simultaneous to all this planning, you had to work out where to put these telescopes, and that led to the site testing project. The Edinburgh people didn't invent the whole idea of site testing. It had been going on for a long time. So let's start with the first site tester. The first modern site tester was Charles Piazzi Smythe, and he was the second director of the Royal Observatory Edinburgh. He was born in 1819 and died in 1900. And just talking about his death, first of all, this is his tomb where he and his wife are buried. And that tomb is actually located about an hour's drive from where I live in North Yorkshire. And the reason it's the shape of a pyramid is because in later life, he became very interested in the Egyptian pyramids and measured them and, made all sorts of theories about them. But before that, in 1856, he borrowed a yacht, and with his wife, he sailed from Scotland via Madeira to the Canary Islands, and specifically to Tenerife. And on Tenerife, he set up a telescope at Mount Guajara, which is about 10,000 feet up near Mount Teide, which is the high point on Tenerife. He made observations there for several weeks and compared the seeing on Tenerife at high altitude with the seeing in Edinburgh. And here is his drawing of a double star. So this was the image of the double star he saw from Edinburgh with the same telescope. And this is the image he saw from Guajara in Tenerife. And as you can see, the seeing conditions on Tenerife are far superior. He was a very distinguished astronomer. He had a crater on the moon named after him. This is a close-up view, Piazzi Smythe, near Plato. So he's on the moon. And another thing he did was he took stereo photographs while he was in Madeira. And if you look cross-eyed at this photograph and merge the two, the left hand and the right hand image, you can actually see a stereo version of his wife and a telescope and a tent. And this was photographs that he published in his book, published a couple of years later. This is the book, Tenerife, An Astronomer's Experiment. And obviously the original is out of print now, but there is a copy from Cambridge University Press, I think, and you can buy that on Amazon. I have a copy of it. It's an excellent book, and you can see all the stereo photographs in it. In the book, he quotes Newton. Newton said in his Optics 1730, telescopes cannot be so formed as to take away that confusion of rays which arises from the tremors of the atmosphere. The only remedy is a most serene and quiet air, such as may perhaps be found on the tops of the highest mountains above the grosser clouds. And this is the first record, as far as I know, of somebody suggesting that really to do optical astronomy, you need to go to high mountains, you need to be above the clouds. This was Newton's idea from 1730. So this is a major influence on sight testing. And then Piazzi-Smythe took it up and actually did the experiment and proved that this was true. However, Piazzi-Smythe was not able to persuade colleagues or the British government to invest in an overseas observatory in the sort of 1860s. He was really 100 years of his time ahead of his time as far as this country is concerned. And it was not until the late 1960s that UK astronomers were happy with the idea of sighting their telescopes on overseas mountaintop sites. In the United States, it was a different matter because in California in particular, there are a lot of mountaintop observatories. And Professor Merle Walker, who was based at Lick Observatory, part of the University of California, became very interested in testing for sites. This is Mount Hamilton on the left, the Lick Observatory. And the Lick Observatory is the first mountaintop observatory that was established anywhere in the world as a sort of institution on top of the mountain to take advantage of good seeing and being above clouds. Now, if you do a time exposure of the sky in the Northern Hemisphere and you point your camera towards Polaris, this is Polaris, you get, and if you keep the camera shutter open for a period of time, in this case it's several hours, you get this trail, these star trails. And Walker's idea was to see if you could use this technology to work out the seeing at a particular site. And so what he did was he set up a 6-inch refracting telescope on a mount at Lick. And he took a series of trails of Polaris. This is a camera at the bottom. And here you can see these are negative images. As the Earth rotates, the telescope moves, hang on, let's get this right. Yes, as the Earth rotates, the telescope moves over the image of the star. And so what you get is a trail. And he compared the trails he got exposed on black and white film with the image that he could see from the 3-meter reflector telescope at Lick. And he came up with a series of sort of standard set, if you like, of trails. So at the bottom we've got very poor seeing, and at the top we have very good seeing. And his idea was that you could set up these so-called Polaris trail telescopes on any site you wanted to test, take maybe a 15-minute exposure of Polaris, and then process the image, and then you compare the image you get from a given site with the standard set and work out what the seeing was at that particular time. So this was his big contribution to site testing. And the Edinburgh group adopted this idea, made copies of the Lick telescopes, and sent them off to various sites to test. After doing quite a lot of work in California, Walker concluded that the best seeing occurs at sites on peaks near sea coasts having cold ocean currents offshore that reduce the height of the temperature inversion layer, and where the laminar airflow set up over the ocean still persists. The inversion layer is where, normally as you increase your height, the temperature decreases. But in certain conditions, it actually increases again for a short period. And in situations where that happens, the inversion layer, the lower part of the inversion layer, traps pollution and also forms a cloud layer. And the air above that layer is much purer, much more transparent than below. And so this is a very important concept for considering sites for optical astronomy. He also thought that mounting peaks on small islands may be good sites, provided that the peaks are sufficiently high to place the observer above the inversion layer. So now we come to the criteria. What makes a good site for an optical telescope? Well, you obviously need a lot of dark hours, and that means that it's no good going to the pole, because at the pole you've got six months of darkness, 6 months of light, and what you want to do is to observe throughout the year. And so if you have a latitude nearer your tropic, then you're going to maximize your dark hours throughout the year. And that means that you've got to place your telescope around between 20 and 30 degrees, in this case north latitude, we're talking about the northern hemisphere. You want minimum cloud cover. You don't want any light pollution or busy air routes. You don't want aeroplanes flying over your telescopes all night. You need good seeing, and that implies above an inversion layer. You want low humidity, because although you may be using mainly optical wavelengths of light, you may also want to use a bit of infrared. And if you have low humidity, then you can observe also in the near infrared. The site has to be accessible, obviously, and you want it in a place with stable politics and friendly locals. Otherwise, the investment doesn't really work. So let's talk a little bit about some of these details. We're talking about a set of optical telescopes. And so these telescopes are going to be observing in visible light. They're not going to be concerned with high energy gamma rays or with radio waves. It's just this little narrow window in the middle of the electromagnetic spectrum. And this window is, the atmosphere does not obscure this window, whereas for higher wavelengths, the atmosphere does obscure them, and in the infrared there are certain narrow parts of the spectrum that will come through, and then in the radio window you've got quite a lot. So we're concerned with this area here, and I've just put this this picture in. This is the image of planet Earth taken on the 14th of February 1990 from the Voyager 1 space probe. The Voyager 1 space probe, you may remember, was launched in 1977 and flew past Jupiter and Saturn in 79 and 80 respectively, and then out of the solar system. And it's been operating for over 43 years now. And the idea was from a range of about 6 billion kilometers to turn the spacecraft around and take an image of the Earth from such a long way away. And so what you need to think about is that, astronomers are all on this little dot, and what they're doing is they're sampling radiation coming from all over the universe, which just happens to be impinging on this tiny bit of real estate, this tiny planet. And so, we're just we're trying to sample tiny bits of the available radiation and make sense of it. Now, I mentioned cloud cover. Obviously, you want to avoid the equator, because although the equator you might think might be good for an optical telescope because you can see the whole sky, unfortunately, it's rather cloudy, and so the equatorial region has to be avoided for optical observatories. And if you look at this weather image, this is a weather satellite image, I think also from about the 1970s. You can see that there's less cloud up here or down here. In the middle, there's some cloud also near the northern bits. So again, this suggests that you want to sight your telescopes, between sort of 20 and 30 degrees north latitude. Now let's talk about seeing. This is a nice image of a double star taken by Damien Peach in good seeing. And if you can imagine photons coming down through the atmosphere, there are lots of layers in the atmosphere, and some of these can be quite turbulent. And so although the images may be fine in the higher reaches of the atmosphere, by the time they get through turbulent layers, the wavefront of the image is perturbed. And what you get then is this rather poor seeing. And so, it's really important when you're sighting a telescope to find a site with good seeing, not like this. This is Van Gogh's impression of poor seeing, and somebody else has massaged the image to show what it would be like without all the swirl. So bad seeing here, good seeing there. This is what we're after. Another thing we have to avoid is light pollution. Wouldn't it be nice if all cities were lit in this again, Van Gogh way? If all cities were lit like this, we wouldn't have any problems with this sort of horrendous light pollution. If you look from space, you can see that a lot of Europe, in fact, most of Europe, is covered in horrendous light pollution. The Royal Observatory Herstmonceux, Greenwich Observatory Herstmonceux, was just about here near Eastbourne. And when the Isaac Newton telescope was sighted there, it was subject to light pollution from Eastbourne and also from London. But if you look at a global map, you can see that large areas are free from light pollution, in particular in the oceans. And here, for example, the Canary Islands, this is Hawaii. And so it is possible to get away from light pollution, and that's really important. Another aspect to consider is the transparency of the atmosphere. This is an image of cactus from America, and the sun is behind this cactus, but there's a sort of a haze of white light because of scattered light from dust. Whereas if you compare that with this image, the sun is behind the anemometer, and as you can see, this is I think from La Palma. There is actually no scattering at all. This is a coronal quality of sky, and that's again something you want. Sometimes the dust from the Sahara is blown across the Canary Islands. In fact, I think recently we've even had it as far north as the UK. And this can be a problem. This is an image by David Malin taken from La Palma when the dust was in the air, and you can see it does affect the sky. So this is something that needs to be considered when sighting telescopes, and this is a device that we used, a night sky photometer, for making measurements of the night sky extinction. And this is just a time exposure of a night sky photometry session. Okay, now we're going to get on to the specifics of the Northern Hemisphere Observatory site testing project itself. So the project ran from 1970 to 1975. It involved maybe 40 different site testers. They tested sites in Italy, Madeira, Canary Islands, and Hawaii. Following really the pioneering work of Charles Piazzi Smythe from Guajara in 1856, where he set up camp and a telescope. This is exactly what the site testers did in the 70s. And the headquarters of the site testing project was the Royal Observatory Edinburgh, and the man in charge was Bennett McInnes. And this is Bennett, and this is Merle Walker behind on a visit to La Palma. The first two site testers who went to La Palma were Thomas Goff and Crispin Heath, and that was back in 1972. I think they went for a couple of months to test it out. So they were the pioneers in La Palma. Okay, so I now want to just show you a table of which sites were considered, which sites were tested. We call the sites, we call them stations. So the first one that was tested was in Italy at a place called Castelgrande. And the reason that Italy was chosen as the first site was simply because Professor Brooke had dealings with Italian astronomers, and he knew of an existing site in Italy used by Italian astronomers, and you know, it seemed at the time to be a potentially good place, and so they did test it for 9 months. It was found to be not really very suitable, a lot of cloud. There was a site in Spain at Cala Alto. This was to be the site of a German observatory, but the site testers were not actually given permission to test there because it was deemed that the Germans already have enough information about the quality of the site, and so we weren't actually given permission to test there at all. So although it was on the list, it was never actually tested by the Edinburgh group. On Tenerife, Izania, which is an observatory belonging to the University of La Laguna, that was tested for 19 months altogether. La Palma, Fuente Nueva was tested for 14 months. The main peak on Teide was tested just for a couple of nights, just to check it out really. It was never really considered to be suitable. There are active fumaroles on Teide, and it's just not a suitable place. Fogo in the Cape Verde Islands was tested for 3 months, found to be a bit too dusty. Note that the latitude of Fogo is 15 degrees, possibly a bit too far south anyway. Hawaii on Mauna Kea at 20 degrees north latitude was tested for 22 months and was a very serious contender. And if for any reason the Canary Islands had not been available to the UK, I think we would have gone to Hawaii. Madeira was tested for 15 months in Cumiada Alta. It was found to be just a little bit too low, so that the inversion layer, whilst normally in Madeira at about lower than 1,500 meters, sometimes did come over the site, particularly in the winter, and so it was just a bit too low. And then we also tested Guajara on Tenerife for 3 months, but that wasn't quite as good as the other sites. La Palma was definitely the favorite and was ultimately chosen. So the Pacific Island sites to be considered, well, it was only really one. It was Mauna Kea on top of Hawaii, on top of the big island of Hawaii, nearly 14,000 feet high. And it is an excellent site. A lot of telescopes established there. The UK put the 3.8 meter UK infrared telescope there. And of course, there's the Keck, the 10 meter and so forth. So, it's an excellent site. But from the UK's point of view, to be honest, really preferred to be not so far away. It's a long journey to Hawaii, and if you can put a telescope a bit closer in the Canaries, it's preferred. The other problem is because it's at 14,000 feet, human efficiency isn't so good at that height because of lack of oxygen and so forth. And it's actually easier to work at a lower altitude. However, from the point of view of infrared astronomy, Hawaii is pretty much essential because you're well above any humidity, and it is an excellent site. In the Atlantic, first of all, by the way, Castelgrande is somewhere here. This was one of the sites tested but rejected. The Azores were considered, but they're perhaps a bit too far north. Pico was looked at, Pico in the Azores, an 8,000-foot mountain. Never tested, but they did do an inspection. Madeira was tested, Tenerife was tested, La Palma was tested, and then in the Cape Verde Islands, Fogo was tested. But I'm really going to focus now on Madeira and the Canaries. I personally worked on Madeira and Tenerife and La Palma. I did not work on Fogo. And so I'm going to talk about mainly Madeira and La Palma. So this is a closer look at these island sites. Not all of these images are to the same scale, but if you look at Madeira, I mean, this is also the same scale. So Madeira is roughly the same size as La Palma. Tenerife significantly bigger. Fogo is a bit smaller. And it's not a huge island. Look, I mean, it's what, 30, 40 kilometers in that direction, maybe 20 in that direction. We're talking about quite small islands. One of the attractive things about La Palma is that the site, which is on this ridge here, this ridge of the caldera, the prevailing wind is from the north. And so what you've got is a lot of ocean, an inversion layer, maybe 1,000 meters, nice, clean laminar airflow, flowing up the side of the mountain and over the telescopes. And this was thought to be almost ideal from the point of view of getting steady, good seeing. And that's what it turned out to be indeed. In the case of Isania, which is somewhere here, the wind direction is here, but there's a bit of turbulence caused by local topography and possibly also proximity to Teide, the 12,000-foot mountain here. So the seeing wasn't quite as good on Isania as it was in La Palma. Madeira, the site is somewhere here in Cumiada Alta. This is a significantly lower site. And so, although again, the wind direction is mainly from here, very good seeing, very good conditions in the summer, but in the winter, the cloud layer quite often came up over the site and prevented observations. And the problem with Fogo was partly the dust from the Sahara, and partly also, I think, the topography of the caldera gave rather poor seeing. So the results from Fogo were not particularly promising. La Palma was always the favorite site. So now I'm going to talk about what we actually did as site testers, what data we obtained. So every night, every hour of every night, we took the temperature, the humidity, the wind velocity and direction, estimated the nighttime cloud cover. We also recorded the hours of sunshine using one of these machines that you have this ball of glass which burns a little hole in a piece of paper, and that gives you the sunshine hours. Precipitation, we had a rain gauge, usually 0. And we also took photographs of Polaris, and occasionally we did night sky photometry, not very often. So the job of the site testers was to collect all of this data every night for, ideally what you wanted to do was get this data every night for a year on each site and then compare them together and see which one wins. The Polaris trail photographs, the films were sent back to Merle Walker in California, and he processed and then assigned seeing estimates to each trail. So he was an essential consultant for the project, and he provided the data on the Polaris trail telescopes. Here are some instruments that we used. So wind vane, anemometer, Stevenson screen with the thermometers inside, a Polaris trail telescope set up on a mount made locally from stones and concrete. This is the night sky photometer, and also on La Palma, later on we erected masts with temperature sensors just to see if the seeing varied with height. So each of these sensors was a meter apart, and we had a chart recorder for the output. And it turned out that really, to be honest, once things had settled down in the evening, the temperature fluctuations hardly varied at all. You know, you had nice laminar flow over the site, and this means that you don't really have to put your telescope on a very high tower to access good seeing. So now we'll just give you a bit of an insight into some particular sites. And we'll go first of all to Madeira, which is where I went in June '74. I went there for 7 months initially. We had a Land Rover. We were based in Funchal and drove the Land Rover up to a point here, Pico de Arriero. Then we had to walk for a couple of hours to get to the site. It was a spectacular walk. It's one of the greatest walks in the world, probably, for hikers. Lots of stone steps, a narrow pathway with some tunnels. You go through some long tunnels, and occasionally, if the conditions are right, if the cloud layer is right and the sun is at a low angle, you can see this interesting optical effect. This is called a glory or a Brockenspector. And so this is the observer. This is me actually taking a photograph of my shadow surrounded by this rather interesting halo. And sometimes you may see this from an aeroplane, but we quite often saw this very interesting effects on Madeira as we were walking to the site. So there were normally 3 observers. One was off duty in Funchal, and the other 2 were working for 10 nights. And then every 5 days, one observer would go up, another one would come down, and they'd swap and take the Land Rover down. And you know, it was quite a good way of working. So this is Funchal in Madeira. By the way, Andrew did visit me later on that year. This is him. We were going on a boat excursion to a local island. This is
Well, if I can just interrupt briefly, I just wanted to point out to people that the walk to your site was quite an incredible walk. I remember the first time I did it, I just couldn't believe it, because you were going up and down these staircases, and usually what would happen, the clouds were drifting in across them, and then you'd be walking through. These were sheer drops. You can see where the 2 figures are in the middle picture. It was completely sheer drop of I don't know how many meters below, and the only thing stopping you was a very rickety sort of rail which was broken in some places, so you were walking along this narrow ledge sort of cut into the cliff, and then every so often you'd walk through these tunnels, and this tunnel was quite a nice one because you can actually see daylight out the other end of it. There were some you walked into and they were completely black because they went round corners, and so if you didn't have a torch, you would just have to sort of feel your way gingerly, putting your hands against the stone walls, which were usually dripping with water. So it was a very exciting commute, if you might say. Anyway, sorry, Paul, to interrupt.
No, that's fine. Yeah, so this was our commute to the office. The office was here, and this was our commute, and it was very exciting, I must say. Now, on top of the mountain, we had a hut and surrounded by a stone wall. By the way, that's the rain gauge. And the reason for the stone wall is that occasionally the winds reach hurricane strength. And so the idea of the wall was to act as a windbreak so the hut didn't get blown away. This is the inside of the hut. That's me and that's Donald. That's the map of Madeira on the back. You can see here's the washing up. This is the washing up bowl. There's a torch. What else have we got? This is a Tilly lamp. We had our illumination by Tilly lamp. This is a gas heater and some music cassettes, and there's a shortwave radio to get the World Service, BBC World Service, for the news.
Well, if I could just interrupt again, one of the other things which isn't evident from this picture is the cereal packets. The cornflakes were usually strung up from the ceiling on pieces of string to stop the mice getting at them. I guess that was another hazard.
Yes, we had mice and lizards that could easily get in the hut, but that was an occupational hazard, as you say. So this is the setup on Madeira. We had a Stevenson screen, an anemometer. We actually had two Polaris Trail telescopes for a while to compare seeing on different parts of the ridge. And so every 5 days, one of the observers would come up with a backpack carrying food for the next 5 days. We also employed local labourers to help us build the wall, and also to bring up gas supplies and any other equipment we needed. There were no mules on La Palma. On other setups, we used mules for transport, but on Madeira, we had to employ local labourers. They were very good, very strong young men, and they walked up from Santana all the way up here, bringing, they brought all the wood for the hut. They helped us build the hut, and they often went for water. The water supply was a spring a little bit below the site, and we had 20-litre plastic containers which we'd occasionally go and fill up, or if we were feeling lazy, we'd pay the boys to go and fill them up for us. So the routine was that you got up at about, let's say, 1 p.m, had breakfast, then checked out what was going on in the station, and then about sunset you'd start the nighttime observations. And if there were two of you on the site, you'd take it in turns to go and do your meteorological observations and take the photograph through the Polaris Trail telescope. And so you do that for maybe 8 hours until dawn, and then you go to bed. We had a couple of bunks in the hut. We had foam mattresses and sleeping bags. It was quite comfortable. The hut's about 3 meters by 5 meters, which is perfectly adequate for a couple of site testers. And then every 5 days, one of you would go off duty and go back to Funchal, where we had a hotel room, and have be able to wash your hair, for example. While we were on the site, we didn't we didn't have showers or anything like that. It was pretty basic, but it was fairly dry and quite comfortable, and we had a great time, actually. Okay, after La Palma, I spent a couple of months on Madeira, on Tenerife, at Izania, and then I transferred to La Palma for the rest of the site testing project. So the site on La Palma is up here. Santa Cruz is the main town, but we were actually based in Los Llanos, which is over here. And we accessed the site by taking a Land Rover somewhere here and then walking up. Later on, when the site was developed, a road was built on this side. You can see on top, this is looking down into the caldera, into this area here. So on this day, the cloud layer was at a low level. And if you look carefully, you can just see Tenerife. You can just see this. This is Pico on Tenerife, Pico de Teide, which is over 100 kilometers away, I think. And here at night, this is the same view, but here you've got the shadow of La Palma rising up into the evening. This is the Polaris Trail telescope set up pointing at Polaris. There's an aerial there for walkie-talkie communication, and that's just the same view at night. Now, to get supplies to La Palma, again, what we did, we lived in Los Llanos, took the Land Rover up a track to a place called Guanyanes and then walked from there. But if we needed to send supplies up, then the mules would meet the Land Rover at a prearranged time, would transfer the equipment to the mules, up they'd go, up this path here, right to the top, took a couple of hours, and that's how we got our, heavy supplies to the site. We didn't have to get people to carry it. Well, actually, here's a chap carrying a box as well, but normally they went up on mules. And there was a little shop at Punta Gorda, which is where the mules were based. And so every 3 or 4 days, we placed an order, and the mules would just come up directly to site with fresh bread or cheese or whatever we needed. And of course, every time we changed over observer, we would send supplies up on our backs with a rucksack. Accommodation on La Palma was similar to Madeira, but we had an extra hut. Again, 3 meters by 5 meters. I think they were lined with cork. I wasn't involved in building any of the huts because by the time I arrived, the huts had been built by other site testers. This is this particular hut going up, Malcolm and Hamish. I'm pretty sure the wood was ordered and just brought up with the mules, and then we just used nails and screws to put them together. This is the water supply on Fuentenueva. It's down below the hut, and it's a very slow running spring. And so what you had to do was use a little tin to go into the pool of water and then laboriously fill up the 15 or 20 litre container with this tin. It took about half an hour to get enough water. It was perfectly pure water, and it was enough to keep us going. On La Palma, we actually had a pet dog whose name was, yes, Doggy. And Doggy used to accompany the site tutor going off duty down the mountain, and then the site tutor coming on duty. Doggy would follow him up and lived mainly on site. And she was a very friendly dog. Granges Bertru at Hassansu, but I got a couple of months off to go and join this project. So the Iraqi Science Research Foundation invited the site testers to help them set up a project to select the best site for a new observatory. And the director of the observatory was Dr. May Kaftan, who died last year, I think at the age of 92. There were 2 locations in Iraq that were considered. Interestingly, it's roughly the same latitude as Malta. So there was one site at Sinjar near the border with Syria, and another Mount Korek, which is quite close to the border with Iran. The highland areas in Iraq are in this area. And of course, this is Iraqi Kurdistan. All of this area is Kurdish. So here's a picture of Mount Sinjar on the left and Mount Korek on the right. You can see the latitudes are similar. Elevation in this case is about 1,400 meters. Elevation in the case of Korek is over 2,000 meters. And Korek does get snow in the winter. When I went to Iraq, I was quite skeptical about the idea of finding good sites. Obviously, there's no ocean-induced inversion layer, and I don't think there is an effective inversion layer there at all. But nevertheless, we did find that both of these sites were quite promising. So we went out in summer. We started in July '77. Very hot. I mean, in Baghdad, up to 48 degrees. and the locals cool off in the Tigris. One of our first jobs was to go around the local souks and source equipment for the sites, for example, poles for the anemometers and cables, etc. When we got to Sinjar, we found that we had access not to mules or porters, but to helicopters. This is a Russian-built Mi-8 helicopter, and it took us from the base camp up to the top, dropped us off with our equipment, and it was a very efficient way of getting equipment up and running very fast. It was very exciting, I have to say. Here is the camp at the place we called Chelmira on Sinjar. We had army tents, and you can see there were actually quite a lot of people involved. These three are my companions from the UK. The rest of this is Dr. Rameh Kaftan, the head of the unit, and these are the other engineers, the Iraqi engineers who worked with us. We had water supplied, I think, by mule and kept in these containers, not just for drinking, but also for mixing cement so that we could build the Polaris Trail telescope mount. We had bunk beds elevated above the level of the ground, and this turned out to be important because on the ground there are things like scorpions and even snakes. So it was a good thing to be elevated by even a couple of feet. Here is a picture of us building the mount. We used local stone and cement, and there's the finished product. The point I made about, its inaccuracy, this is pointing roughly at Polaris, but in order to sight on Polaris, you have to adjust the bottom ring, and as long as you've got Polaris in the field of view, you'll get an image. But precisely where Polaris is in the field of view doesn't matter from the point of view of sight testing. And to be honest, you could never use the data that we got for checking on precession or anything accurate like that. This is Mount Korek in the Kurdish area. If we look at the average temperatures, you can see that in the summer it gets up to over 30. A minimum temperature might be 2, but it'll go below 0 in the winter. But there's quite a range of temperature. And then in terms of rainfall, again, in the summer it's completely dry. In the winter, a little bit of rain, not too much, but there is some snow, and so that is, that could limit your access. Nevertheless, the Iraqis did build a road up. Mount Korek turned out to be the favored site. The reason for these two images down the bottom is that our first attempt to get to the site didn't go according to plan. We were traveling in a four-wheel drive Toyota, I think, behind two army jeeps. And there was no proper road at that time, just going up a very steep ascent. And every 5 minutes or so, the army jeeps stopped, and the soldiers got out, raised the hood, and then they went to the back of the jeep, accessed a prolific supply of watermelons, cut a watermelon in half, and then applied it to the overheated engine. They basically put a watermelon directly onto the engine block to cool it down. This happened a number of times, and I thought, well, this isn't going to work. So eventually we abandoned that particular attempt to get up the mountain, and the next day we went up in better army lorries and got there in about 45 minutes without stopping. But it was quite amusing to see these soldiers applying watermelons to their jeeps. If we look at the results, we've got the comparison: Sinjar about 1,500 meters, Korek 2127, latitude around 36. But if we look at this table here, seeing in arc seconds, again, we sent the films to Earl Walker to do the analysis, and you can see that Korek is significantly superior in terms of seeing as opposed to Sinjar. And so Korek was selected by the Iraqis as the site for their new national observatory. Finally, we get to the legacy. La Palma has a huge fleet of telescopes, a very successful observatory over the last 40 years or so. By contrast, Iraq has some telescope buildings, but unfortunately, because of the wars in Iraq, talking about the unstable political situation, these buildings were damaged. And so the Iraqi setup is not functioning and not likely to function again. And finally, there is a new book which has just been published about the history of astronomy in Madeira, but it actually includes a lot of detail about the site testing project. Unfortunately, it is in Portuguese. The author, Pedro Augusto, hopes to publish an English version at some point, but at the moment it's only in Portuguese. If any of you are fluent Portuguese readers, then you can get a lot of information from this book. Okay, now I'm going to